In this example, we are going to take a function f of x, which is x plus 7, take x and add 7, and g of x, which is the square root of x. We're going to compose these two functions in various orders in a, b, c, and d, and then state the domain for these various composite functions. So starting with part A, we are looking at the function g composed with f of x. And so this open circle notation means compose, not multiply. So the order does matter here. This means we're taking x, first plugging it into f, and then we're taking that result and plugging it into g. So in the end, this is what we would get if we first evaluated f of x and then plug that into g. So we can write that as g composed with f of x. And we can do this in different ways. So here we can discuss different ways that you can try and simplify this expression. One of which we'll call the inside out approach. And so what this means is we first take the inside function f of x, which is x plus 7. And then we're going to take this and plug it into the outside function, which is the square root of x. So I'm going to leave a little blank for each x that I see. And sometimes we might have expressions that have more than one x on the outside function. So for each x, in this case there's just one, I leave a blank. And when we evaluate functions, what it means is take every x and replace it with whatever is going into g. In this case, that's x plus 7. So each of these blanks that we have for x, we're going to replace with x plus 7. So that gives us the square root of x plus 7. And there's our composite function. We could think about this by starting with the outside in approach. And you don't need to do both of these, but you might want to try these methods and see which one you like best. Some might work better in some situations than others. So here we start on the outside. So we've got g, and we're plugging f of x into that. So I'm just going to write these in different colors. And so g is the function that says take the square root. So again, I'm going to take each x in the expression for g and replace it with whatever I see here. So each x is going to get replaced with f of x. And then I replace the expression f of x with x plus 7. That's what f of x is. And this gives us the same result. So in the end, either way, we get the square root of x plus 7 for the composite function. And this should make some sense, practically speaking. So in this case, f tells us that we should add 7. And g tells us take square root. And so if we first add 7, and then take the square root, that's exactly what we would expect to get, x plus 7. So that's what it means to compose these operations. And to find the domain, let's just recall that we have a square root here. And if we try and take the square root of a negative number, that is an undefined operation. So we need to make sure that whatever is inside the square root, in this case, we need to make sure that x plus 7 is not negative. So in other words, it's greater than or equal to 0. And solving that inequality would give us x is greater than or equal to minus 7. So we're expressing that in interval notation, we would say from minus 7, including minus 7, to infinity. And just be sure that you do want to include minus 7 in the domain. because plugging in minus 7 would give us 0 underneath the square root, which is fine. The square root of 0 is 0. So our domain is all x values greater than or equal to minus 7. So let's take a look at parts B, C, and D on separate slides. In part B, we're taking the same functions for f and g. The square root of f is x plus 7, g is the square root of x, and now we're changing the order in which they're composed. So in A, we first did f and then g. Now we're going to first do g, and then we're going to apply f. So for part B, let's say we do this using the outside-in approach that we discussed in the previous example. That means we would take f of g of x, and the first thing we do is we start on the outside, which is x plus 7. So just like before, we're going to leave a blank every time I see an x in the outside function, and then this tells me what goes in each of those blanks is g of x. So for each of those blanks, for x, we plug in g. And then we evaluate this by replacing g with its operation, which is the square root of x. So this would give us square root of x plus 7. In other words, square root of x plus 7. Okay, and so notice this is different than what we got in part A. Part A, we got first add 7, then take the square root. This is telling us first do g, which is take the square root. Once we get that result, we add 7. So the 7 is not inside the square root symbol. To find the domain of this, we've got a square root, and so we just need to make sure that we don't have anything negative underneath any of the square roots that we see. So in this case, we have one square root with x underneath it, so we just need to make sure that x is greater than or equal to 0. So as long as that's the case, we're not going to have any problems when I plug in a value. So I would take the square root of that number, and then we could add 7 to it. So the domain here is all values of x greater than or equal to 0, which we could write as 0 to positive infinity. Okay, so next let's move over to part C on the next slide. In part C, we're now composing the function g with itself. Okay, so that's fine. We can compose an operation and perform that same operation a second time. So in part C, this is saying g composed with g of x. So what I could do is say, well, what is g of x? This one we can start on the inside. G of x is the square root of x. And then I'm going to plug this into the outside function. And so the outside function, again, is the square root. So I've got the square root of x, and I replace each x in the outside function with the expression for the inside function. So what this is saying is take the square root of the square root of x. And that is equivalent to taking the fourth root of x. And the domain here is we would take a look at x, which is going into the square root. And so again, if we want this thing to make sense, we need to make sure that what gets plugged into it is greater than or equal to 0. So for the domain in part C, first we need to make sure that x is greater than or equal to 0. And as long as that's the case, then I can do the first square root, and that's going to give me something. What comes out of the square root is something that is bigger than or equal to 0, so there's going to be no problem with taking the next square root. So the domain for this function would be all x greater than or equal to 0, which would be 0 to infinity. And finally, in part D, we're now composing the function f with itself. So here, f composed with f means I first take x and plug it into f of x, the inside function, and then we take that result and plug it into the outside function, which is f of x again. So replacing the first x, say in the outside function, we could take f of x and plug it in here. And then I can replace f of x with its expression, which is x plus 7. So simplifying this, we're adding 7 and then adding 7 again to that result. We get that f composed with f is the same thing as x plus 14. Okay, that makes sense. If I take a number, add 7, and then add 7 to that, it's the same thing as taking a number and adding 14 to it. And for the domain of this function, we don't have any problems. For any number x, I could add 7 to it. That's going to give me a new number, and I can add 7 to that again. So there's no problem with the domain here. There's no values of x that will lead to an undefined operation. So in this case, the domain is all real numbers from minus infinity to infinity.